So we're continuing on with our discussion of IP addressing on frame relay. We've just talked about manually specifying DELCs for subinterfaces, and speaking of DELCs, frame relay normally auto-learns the correct DELCs for the correct virtual circuits. And it does this so that it can create a map that associates a layer 3 address with a layer 2 DELC so it knows what DELC to use to reach the next hop address. Kind of like ARP on an Ethernet network. And in fact, this whole process is called inverse ARP. It has kind of the same functions as ARP on an Ethernet network, but it works a little differently, and I've got a little diagram on the next slide that'll show you exactly how inverse ARP works. Now you can also build the DELC map manually. Building the map manually is rarely done on production networks because, again, that's just one more manual configuration to have to maintain, and it follows the same logic as static routes. It's essentially a layer 2 static route. Every time you go add a DELC to a particular site, you have to go and manually update the frame relay map commands in that router. However, since we're on the exam and not necessarily in the real world, you will have to know the commands for the exam, and we will show you how that works in the lab. So let's move on to inverse ARP. Now I've simplified our frame relay networks, only have 2 points here, and you'll see we have DELC 101 in Dallas, DELC 200 in Birmingham. However, since we're talking about inverse ARP, I've also added the IP addresses on here, 192.168.1.1, 192.168.1.2 over here in Birmingham. Now as we talked about, LMI is a keep alive protocol, and so once you have established an LMI, the LMI says, hey, this DELC is up. DELC 200 at the Birmingham site is up. DELC 101 in Dallas is up. And I've got a double-headed arrow here, but obviously this is the local loop maintenance, so DELC 101 could be up, but DELC 200 could be down. So essentially, LMI tells the router, hey, your DELC is up. At that point, each router broadcasts over that DELC that says, hey, I am 192.168.1.1, and it sends it out DELC 101. Now, if you'll recall our discussion of frame relay rips out that DELC 101, substitutes DELC 200, and drops it on the Birmingham router. Birmingham gets the message that I am 192.168.1.1, and it sees it's coming from DELC 200. So Birmingham says, oh, DELC 200 is how I get to 192.168.1.1. It puts that in the local frame relay map. And Birmingham also sends back the same message that says I am 192.168.1.2, sends it out to DELC 200. The frame relay network knows that DELC 200 in Birmingham maps to DELC 101 in Dallas, so it rips out the 200, substitutes the 101, and drops it on the Dallas router. Dallas sees DELC 101 is how I get to 192.168.1.2. Dallas adds it to its map, and so now you have both layer 2 mappings by virtue of the LMI. You also have layer 3 mappings by virtue of the inverse ARP. And again, this works pretty much automatically, and in every production network I've seen, the engineer lets it work automatically, but you have to know this whole process, and you have to know the map commands for the exam, and of course we will go over those commands here in just a little bit. And that concludes, finally, our discussion of IP addressing on frame relay.